Okay, the video we're gonna do today is a little different. You don't see me, but the word is you don't see me yet. So we're gonna talk about horizontal asymptotes, all right? These are the rules. So when the degree of the numerator is greater than the degree of the denominator, then there will be none. So if you look at example 1, that's an example. The 2 is the degree on the top, and then the degree of this x is gonna be a 1. So that's why there is none. We take a step back and we're gonna look at where's the degree of the numerator equal to the denominator. That example is example 2. As you can see, both x, you don't see a degree, but if you don't see it, then that means they're both 1. So since they're the same, you're just gonna divide the 2 and the 5. And that's how you get y equals 2 over 5. And our last case is when the degree of the numerator is less than the degree of the denominator. And if you look at example 3, the x on the top has a degree of 1. You don't see it, but x to the power of 1 is the same thing as x. And then on the bottom, you see a 2. And that's why you get y equals 0. These are not bad. You just have to have the time to get accustomed to them and have it somewhere in your notes. Now we're gonna move on to vertical asymptote. I wrote you a nice little paragraph. I think the big thing that we're forgetting when we do this is, what does it mean? Everybody looks like a problem like this and they're like, well, you just set the bottom equal to 0 and you find it. Okay, that's cool. But the reason why we do that is we are trying to find the x values that make your denominator 0, because you're not allowed to have a 0 on the bottom. So that's why we are taking what's on the bottom and setting equal to 0. Say hello to this problem. We'll be coming back to it. Next, we're going to talk about our famous holes we've been wondering about. So holes happen when you're able to divide a common factor from the numerator and the denominator. So when we remove them, we're removing a vertical asymptote, thus creating a hole, which you will see in our example. Last kind of little definition is, this is the form of a rational function in transformational form. You would treat it the same over here. You would just find it. So whatever you get, that would be a horizontal asymptote. And then you'll just take this value and either add or subtract it. Okay? So let's try to do this example when I get to this one. Sorry for the moving camera. But we're about to set that down, get the angle, and look at that. Here I am. So let's do horizontal real quick. They're both to the power of 2. So you know you're going to divide the leading coefficients. Leading coefficient is a 1. So you're going to get y equals 9 divided by 1, which equals 9. So y equals 9. Next, we're going to find the vertical asymptotes. We're not going to worry about the holes yet. Let's just find out the x values that are going to make my denominator 0. So, I'm going to write dA. I'm going to do x squared minus 8x plus 15 equals 0. We need to review our factoring skills. So, I could put any factoring problem on this test. So, you should review them. And this is just sum and product, decimal check. What two numbers multiply to 15 and add to -3? That has to be -3 and -5. -3 times -5 is positive 15. -3 minus 5 is -8. And of course, we need to set them both equal to 0. And we get x equals 3, x equals 5. These are our candidates. These are possible vertical asymptotes. So, if we can't factor out anything, then this will stay true and this will be good. But if we're able to factor something out from the numerator, then we might have a hole. So our next step is we're going to go back to our original problem and we're going to factor it. And the good thing is, we already did the bottom. We know that it's this. What you're really worried about is the top. So, what do these both have in common? I know they have a 9. And then it becomes x squared minus 9. There we go. So remember, greatest common factor is really helpful because it takes bigger numbers and it makes it smaller. But as you can see, we're still not done because x squared minus 9 is called a difference of squares. So you end up with x plus 3, x minus 3, and we'll copy our bottom. So, as you can see, these are going to divide out, and that means we are going to remove x equals 3, and that means x equals 3 is a whole. That is the process of finding out your horizontal asymptote, finding out your potential vertical asymptotes, and then finding out if a hole exists. On the next video, I'm going to take this next graph and I'm going to graph it and talk about the domain. Thank you.